Hi guys, welcome back to our discussion on infinite series. In this video, I'll talk about root tests. So specifically, we will determine whether a given series converge or diverge using the root test. Okay, how to use the root test? So according to this theorem, let summation of u sub k be a series with positive terms, and suppose that rho is equal to the limits of the kth root of u sub k where k approaches positive infinity. And you can write this as the limits of u sub k raised to 1 over k as k approaches positive infinity. Okay, so in letter A, if rho is less than 1, the series converge. But in letter B, if rho is greater than 1 or rho is positive infinity, the series diverge. But if rho equals 1, the series may converge or diverge, so that another test must be tried. But if you want to determine the convergence of the series using absolute convergence, then uh, we take the absolute value of the nth root na before taking the limits. And if the limits of the nth root of the absolute value of a sub n is less than 1 as n approaches infinity, then we can say that the series summation of a sub n converge absolutely. But if the limits of the nth root of the absolute value of a sub n as n approaches infinity is greater than 1 or equal to infinity, then we can say that the series diverge. Also, if the limits of the nth root of the absolute value of a sub n as n approaches infinity is equal to 1, then we can say that the root test is inconclusive. Okay, suppose for example that you're given a series of summation of e to the n over n to the n power, where n is from 1 to infinity. So our aim now is to determine the convergence or divergence of the given series. So using the root test, we have to evaluate the limits of the nth root of the given series, where the given series is e to the 2n over n to the n. That's the nth root. So by substitution, this can now be written as the limits of the nth root of the absolute value of a sub n. But a sub n is e to the 2n all over n to the n. And when you take the absolute value, this is also the same thing as the nth root of the given series. So because we need to extract the nth root of a sub n, we can raise each term of the numerator and denominator by 1 over n. So you can write this as e to the 2n quantity raised to 1 over n is the same as e raised to 2n over n. Same thing in the denominator. You can write this as n raised to n raised to 1 over n. But e raised to 2n divided by n is e squared, and n over n is 1, so you have n. And then by evaluating the limits of the resulting expression as n approaches infinity, so we replace the n variable by infinity. So we have e squared over infinity is 0. And because 0 is less than 1, so we can therefore conclude that the series converge absolutely and therefore converge. Okay, so in summary, the series summation of a sub n is said to be convergent or converge absolutely when the limits of the nth root of the absolute value of a sub n as n approaches infinity is less than 1. And then second, the series of summation of a sub n diverge when the limits of the nth root of the absolute value of a sub n as n approaches infinity is greater than 1, or if the limits is infinity. The number 3, the root test is inconclusive when the limits of the nth root of the absolute value of a sub n as n approaches infinity is equal to 1.